Okay, so here's another example that you should try first, and then I'll go over how to do it. So imagine you have one where you have a mass of 7, and the initial velocity of this object is 20 meters per second. Then it's hitting another object with a mass of 10 kilograms that is stationary. So the question is, what will the velocities be of the different objects after they bounce apart afterwards? So remember, set up momentum, and then kinetic energy, and then try to plug in each other. So you should pause the video, and then I will show you the answer. Okay, so here's momentum. We know that the initial momentum is 7 times 20, which is 140. And the second object has no momentum because its velocity is 0. Afterwards, though, we're going to have a momentum of 7 times v1 and 10 times v2. Alright, now looking at this equation, unfortunately there is no way to simplify it further. There's no thing we could divide everything by. So let's go over to kinetic energy. Kinetic energy, we're going to have on the left side 1/2 7 times 20 squared, and then 1/2 times 7 times v1 squared plus 1/2 times 10 v2 squared. So one nice thing here at least is that the 1/2s can all cancel. And so what I'm calculating here is this, which would be 2800. On the right side I have 7v1 squared plus 10v2 squared. Alright, now I'm going to take this equation over here, and I'm going to plug it in the other one. And I'm going to, like normal, get v1 alone first. So 140 equals, we're just going to subtract 10v2 over. So we subtract 10v2 over is equal to 7v1. And let's divide everything by 7. So that would be v1 equals 20 minus, this is going to be 10/7 v2, which is not the prettiest fraction, but we can work with it. So now instead of v1, I'm going to replace v1 with that ugly stuff over there. Alright, so this is going to be 7 times 20 minus 10/7 v2 squared. Alright. The next thing I normally do is FOIL this out. So I'm going to get 2800 equals 7 times the FOILed out thing. So let me see here. I'm going to have 400, it's 20 times 20, and then 20 times this would be negative 200/7 v2, and again I'll have a minus 200/7 v2 plus 149 v2 squared plus 10 v2 squared. Alright, if you need to, just change 10/7 into a decimal and then maybe keep 3 or 4 decimal places so you're accurate. Alright, and then I'm going to multiply everything by 7. So this actually isn't too bad. I'm going to get 2800 here. When I drop 7 in there, it's going to be minus 200 minus 200, which is minus 400 v2. Now this is going to be plus 100 over 7 v2 squared plus 10 v2 squared. What is 100 over 7? I'm just going to give up and go to 14.3. So a couple things happen. These can cancel. We can subtract on both sides and get 0. On the left, we have minus 400 v2. And then when I'm combining these like terms, 100 divided by 7 is 14.3, so 10 plus 14.3, that's about 24.3 v squared. Alright, and like usual, I'll factor out a v2, And swap the sides here. 24.3 v2 minus 400 is all in the parentheses. If I set this equal to 0, I could solve and get my velocity 2. So it's been a long road. I add 400 to both sides. I divide by 24.3. What's 400 divided by 24.3? That's going to come out to be 16.5, basically, meters per second. Alright, so V2 is having a velocity of 16.5 meters per second. Now I have to go back and plug that in to this up here. So V1 is going to be 20 minus 10/7 V2. That's 10/7 times 16.5. Oh man, I get V1 equals negative 3.6, basically, meters per second. Alright, so V1 is bouncing off the other object because the velocity of the first object is smaller. Sorry, the mass is smaller. But a lot of the velocity goes into the second object because it's not that much smaller. Alright.